Welcome back, everyone. Today I'm taking a look at a printer that's had a decent amount of hype behind it, and that's the AnkerMake M5. AnkerMake launched their Kickstarter for this printer about 10 months ago with this M5. There was a lot of hype behind it because it's generally uncommon for a large company like Anker to enter the world of 3D printers. Yes, this is the same Anker you know of who makes a ton of electronics and is my go-to for charging cables for my phone. This printer launched before the Bamboo Lab line of printers, and I think Bamboo Lab definitely ended up stealing a lot of AnkerMake's thunder. But this printer was definitely a game changer when it first launched. As you can see by my unboxing, this printer came in a very professional package, something you would expect from a large company like Anker. I'll go over the specs while you watch me continue to unbox and set it up. This was the first of the fast 3D printers that were launched in 2022, at least that came packaged as meant to be printed fast, with AnkerMake advertising printing speeds of 250 mm per second and accelerations of up to 2,500 mm per second squared. They say this is possible due to their power boost, which optimizes energy with its Y-axis transmission system. This uses a powerful stepper motor, double belt drive shaft, and stabilized motion algorithm to push out more power for high-speed printing. AnkerMake let me know that for the software algorithm, they optimize the K-value algorithm, dynamic jerk value, command data transmission, and the high-speed motion node deviation, so that the M5 can get higher data transmission efficiency and make better matching of extrusion speed and high printing speed. Now, I agree, this was slightly confusing to me as well, but this, along with the good build quality, means that this M5 can print with high accelerations and print speeds. Along with this power boost, this AnkerMake M5 has a lot of unique positive features. It has a strong dual drive extruder with a large 9.37 reduction ratio, and then has a fairly short distance between said extruder and the hot end. This hot end has a large heating block with an advertised 1.5 times faster melting to allow for those increased printing speeds. There are 2 active cooling fans that blow onto your print and try to help rapid cooling for faster printing. The build quality is extremely sturdy with dual Z lead screws and 2 Y smooth rods and belts. The base on this printer is really hefty, and this printer is a lot heavier than you would assume if you're used to using other bedslinger printers. There is an integrated intelligent camera on the right side of the X-axis that has a 1080p resolution, real-time monitoring, the ability to make time lapses, and most importantly, has AI failure detection recognition. The printer uses its X-Burst CPU for continually checking and comparing your print to the 3D data of the model to determine if a failure is occurring. The M5 then has a separate Marlin CPU for routine processing. Other features include a 7x7 auto bed leveling where the nozzle takes 49 points to make sure your bed is level before starting a print. It comes with a bendable and scratch-proof PEI magnetic build plate, a 4.3-inch touchscreen for controlling the printer, and other doohickeys such as an LED indicator which shows different colors for different activities, and a phone app for you to remotely monitor and change prints. The build volume of this printer is 235mm by 235mm by 250mm, and the price is $799. Let's see if it's worth it. After the pretty simple build, it's time to turn on the machine and run through the setup. This touchscreen seems great and walks you through setting up Wi-Fi, downloading the app for your phone, and then auto-leveling the build plate. This 49-point bed mesh should hopefully help to not worry about ever having an unleveled build plate. Also, no need to figure out the proper Z height. Overall, a great setup. Now it's time for a few notes. It doesn't look like this printer came with any SD card or external drive. This is quite odd since it's the first printer I've ever reviewed that didn't come with some sort of SD card or flash drive. It's beneficial not to just have one, but often tutorial videos and other helpful tricks will be on these flash drives. And then it's a bit of an extra nuisance because this printer takes Type-C. If this took SD, microSD, or a flash drive, I have plenty of those. I don't own a single Type-C flash drive though, meaning I would have to buy one in order to print with an external source. I guess that AnkerMake just assumes everyone will use their slicer and send files to print over Wi-Fi. Before getting to the slicer though, I printed the one included test G-code file. This test piece printed quite fast, and overall I was very impressed. I'm definitely spoiled from the Bamboo Lab and other fast printers, but this was certainly way faster than any other standard printer I have. And overall the quality is actually great. These posts came out with any concern of stringing or blobbing from retraction efforts, the overhangs and bridging came out great, and the only potential negative I have was that it took some effort to get the 0.3mm tolerance test out, and the text for those tolerance tests were hard to read. I would want the 0.2mm tolerance test to pop out for a 0.4mm nozzle, and I would want the text to be easy to read, so there might be a small amount of over extrusion. Aside from that though, really not much to complain about on this opening print. Once that one included print was done, I needed to use their slicer in order to get more prints going. And this is definitely a big drawback of AnkerMake. This slicer is certainly subpar. Looking here, it looks like it has modified Cura, MeshLab, and Slicer to make this program. Overall though, it feels a lot more like a modified version of Cura. The program looks nice, but overall I'm not a fan of how you choose your settings. Easy mode doesn't have nearly enough options, and then expert mode is kind of like you open Cura and open every single setting, and it could be a bit overwhelming. That said, for my first print, I just use it on easy mode and slice up Benchy. I then send it to the printer via the slicer, which worked really easily, and this Benchy took just about 45 minutes. The top speed is 250mm per second, and the acceleration was 2,500mm per second squared. The printer did recognize a false positive for an error, something that happened later on as well in my tests until I lowered the sensitivity, which is easy to do right on the touchscreen. Regardless of the sensitivity, it's a cool feature where you can get an update on your phone with a photo to show what the printer thinks is an error, and then you can choose to continue printing or cancel, even remotely. Something extremely beneficial for you to feel confident leaving your printer while you run errands. What's worth noting though is this AI detection only works when you use their AnkerMake slicer. I will end up using Cura shortly, but it's worth noting that you will only get this AI detection parts if you slice using AnkerMake. This Benchy looks great from a side profile and from the front, but when you look at the back it seems that there's a lot of blobbing. Before getting into the weeds of trying to improve print quality, I slice a torture toaster using the easy mode on their slicer again and then send it to print. This torture toaster normally takes about 15 hours on an Ender style machine that don't have the ability to print fast, and on this AnkerMake it only takes 6.5 hours when at 0.2mm layer heights. Now unfortunately I misjudged how much orange PLA I had, but luckily this AnkerMake and its filament runout detection worked as it should, and I was able to replace it with some white PLA and let it finish. Now unfortunately this is definitely not the best torture toaster I've printed. It took a lot of cracking and finessing to get the toast out and also to get everything to move as it should. And then I was only able to get the 0.5mm tolerance section to move even after a lot of effort. I normally like to see all the way down to 0.2mm move, so 0.5mm is not a good result. Overall, it looks like cooling may have been an issue running at these speeds since the angles aren't the greatest, which I'm sure hurt overall tolerances. Now that those two tests using their easy mode are out of the way, I try to use their slicer on expert mode and fix the areas I think needed improvement. I play around with retraction and lower speeds a bit, and then try to print another Benchy. And while the blobbing isn't quite as bad on the back, it overall wasn't a great print either. Now, as mentioned, I'm just not a fan of how AnkerMake slicer is arranged. I'm sure I could get used to it, but overall it leaves a lot to be desired. Luckily, someone has already made it really easy to add AnkerMake M5 to Cura, which is exactly what I do. I'll leave a link to the GitHub in the description down below. Setup was super simple, and it even has the build plate on it. I'm positive you can tweak all of the same settings on AnkerMake Slicer, but I'm personally far more used to Cura and have it all set up in a way that is easy for me to understand. This GitHub file also has a starting profile to work off of that utilizes the high speeds of the M5. I slice a Benchy using the stock settings included, slice, and then want to print. But since I don't have a Type-C flash drive, I need to use AnkerMake in order to send this G-code to the printer. This is simple, you just need to go to AnkerMake Slicer, click on Device, upload the G-code, and then click Print. It will send the print to the M5 and get started. Unfortunately though, as mentioned earlier, this means that the AI failure detection won't be turned on. And well, this reprint has different issues, but issues nonetheless. A lot of blobbing and an unreadable license plate are just some of said issues. I then make 2 more attempts to print another torture toaster. Both times, slightly tweaking settings I think may help. Both of these prints are certainly improved from the first toaster, and I'm able to move the 0.4mm tolerance test on both, but that still isn't as good as I would have hoped. Angles are also ugly, again I assume from not enough cooling at these speeds. I did reduce the speeds by about 25%, but still no such luck. I get the feeling that this is over extruding a bit, but I don't do any tweaks in this regard for this video. First off, I'm not quite sure how hard it would be to tweak these E-steps, but also because I normally don't like to do this on printers I'm testing, since it shouldn't be expected for a new user to have to worry about extrusion issues. My next test for this video was to just check out how nice this high gear ratio extruder is by throwing some TPU at it. For the unfamiliar, the softer the flexible filament that you use, generally speaking, the more you need an extruder with a short distance between itself and the hot end, and the better off you'll be with the high gear ratio and dual drive. So I load up some TPU 95 from Polymaker and attempt to print a wallet. My first attempt, I just keep speeds at 250mm per second just to see what happens. And as expected, we massively under extruded. I wouldn't expect any printer to print TPU at 250mm per second, I just wanted to see what would happen. I lowered the printing speeds to 60mm per second, and it got a lot better, but still a bit under extruded. So finally I bump up the temperature slightly and lower the top speeds to 50mm per second, and we get a successful TPU wallet print. 50mm per second is a bit slower than I was hoping this machine could do for TPU, but overall not bad. Finally, after showing AnkerMake that the quality on some of these prints weren't the best, they did let me know that their profile settings were tuned in for their PLA+. So they went ahead and sent me a couple of spools just to see how the quality may change. I went ahead and printed a torture toaster and a bearded yell, both of which should be a good test for quality. And while I have to give it to AnkerMake, the quality improved quite a lot using their filament. Of course, since it's white, it's difficult to show on camera, but the quality on both of these prints is superb. Unfortunately, the torture toaster, I'm only able to move the tolerance down to 0.3mm, but it really does look good. And then the bearded yell has basically no flaws on it. While this isn't meant to be an endorsement of their material, it does show the quality of prints this M5 can actually produce is good, just a matter of tuning in the slicer settings properly for the material you're using. It also looks like AnkerMake is currently making changes to their setup since they're now expanding their AI failure detection to update their algorithm for spaghetti monster detection. Instead of using an image-based modeling comparison method, they will adopt a local deep learning model. As they collect more materials, the model will become increasingly accurate and intelligent. Okay, let me get into the pros and cons of this printer before I get into my final thoughts, starting with the pros. This is a very well-built printer. This means it is extremely sturdy, and I have zero complaints on the build quality. Along with the frame being sturdy, the extruder looks like it's really nicely made and uses hardened steel. It's a very professionally packaged printer. Not just the actual packaging that the printer comes in, but also the overall look and feel. Even little things like how the colors light up depending on what you're doing was very well planned out. Not necessarily important for print quality, but it can be important to know that you got a professional product. The build plate is surprisingly good. I thought it wouldn't have parts stick too great, but I didn't have any issues with parts sticking during printing, and it was really easy to remove them. No complaints about this build plate at all. The touchscreen is great, and the user interface is really well presented. You can even perform firmware updates right on the screen. It has a great high definition camera on it, which not only allows for easy remote viewing, but it also means you can have some AI failure detection. It even has night vision so you can see your prints in the dark. The app on the phone is easy to use, and you get notifications for when prints either fail or finish. The bed leveling worked great, and I didn't have to worry about the first layer at all during these prints, which is a huge benefit for new makers. Overall, it's a pretty quiet printer, especially when you're printing at fast speeds. That is certainly a win for this AnkerMake over printers like the Bamboo Lab or the Snapmaker J1 I recently reviewed. Those both are very loud. The quality on the final 2 PLA prints were really good. And then, of course, the speed. As mentioned earlier, what's going on with the software is a little confusing to me, but it, along with the nice hardware, means that it can print at fast speeds and accelerations without a ton of ghosting. And now for the cons. This one shocked me, and something I had no idea until I was editing this video, but it doesn't look like the hot end is all metal. I had just assumed this entire time that a machine such as this would have a hot end that could reach 300 degrees Celsius, but my assumptions seem to be wrong. I tried to set the hot end at 295 degrees, and the printer reset it to say 260 degrees. This is a major negative, since I would assume a printer with all of these features would at least have an all-metal hot end. It uses a Type-C flash drive. This isn't a negative in itself, but AnkerMake should definitely include one for anyone who purchases a printer. I'm sure I'm not alone in the fact that I don't own a Type-C flash drive. It's a bed slinger. If I had a choice in what style of printer I get, I'm going to prefer Core XY, where the build plate doesn't rattle. The AnkerMake slicer is far from the best slicer I've used. I'm sure you could do anything you want with it, just something about how it's organized or presented that I'm not a fan of. That said, I saw announcements that they do plan on switching to Prusa slicer, which would be a welcomed addition once that's live. The AI detection only works with parts sliced with the AnkerMake slicer. This means if you use Prusa slicer or Cura, then the AI detection feature won't matter to you. And then finally, they have their dual cooling fans with good angles as a positive on their features, which it definitely is, but it doesn't look to be quite enough cooling in my opinion to print at 250 millimeters per second. I would suggest reducing top speeds to about 200 millimeters per second to have more consistent results on angles. Alright guys, I was writing this script and was originally going to call this a Prusa killer. If you want a bed slinger printer, then I was going to say that you should definitely get this over a Prusa, especially before the MK4 announcement. That is, until I realized this printer doesn't have an all-metal hot end. I sincerely don't know why Anker didn't have the hot end reach 300 degrees. It is such an inexpensive thing to tweak about a printer, particularly one that has a price point of $800. If you never plan on printing in carbon fiber nylon or other materials that require a printing temperature above 260 degrees Celsius, then it looks like you get way more bang for your buck on this printer than a Prusa, assuming you have the ability to really tweak settings to get a clean print. Along with faster printing, a camera for remote viewing, higher quality and professional build quality, you even get a larger build volume than a Prusa. That said, this is likely more comparable to the brand new MK4 announced by Prusa, and when compared to that, it's a tough decision. It would make a lot of sense to see a side-by-side of this M5 versus that MK4, since it's difficult for me to say which I think would be a better investment. If AnkerMake was looking for any suggestions for me, I would say that this printer should definitely have an all-metal hot end, it should have improved slicer settings stock for higher quality printing, even if that means reducing the speeds a bit, and the slicer itself should be improved upon. If all three of those things were done for a V2 of this printer, then I